Welcome back to Scovia. In our previous videos, we talked about the three ingredients of a random forest and the hyperparameters used to tune the random forest. Today, we are going to talk about how to evaluate the random forest model once it's trained. Normally, the golden rule is to split your data into three parts. First, the training set, which the model learns from. Second, the validation set, which you use to tune those hyperparameters that we talked about in the last video. And third, the test set, which is sealed in a vault until the very end for a final honest report card. But here's the problem. If you have a small data set, carving out a separate validation set means that you're throwing away some of the data that the model could have used to learn. You're starving your model so that you can test it. One common solution is k-fold cross-validation. This is where you chop your data into, say, 5 pieces, and then you train on 4, test on 1, and then rotate until everyone has had a turn. And then average those scores. This is robust, but it's heavy. You have to train the model 5 separate times. If your model is huge or your computer is slow, this can take forever. But if you're using a random forest, you have a secret weapon that gives you the best of both worlds: accurate validation without the extra work. It's called out-of-bag evaluation, or OOB. Remember that random forest uses bootstrapping or bootstrap sampling, which means each tree is trained on a random selection of rows, usually about 2/3 of the data. That means for every single tree, about 30% of the data was left out, right? It was left out of the bag. That tree has never seen those rows. So here's the magic trick. To test the model on a specific row of data, we find the trees that didn't see that row during training. We ask only those trees to make a prediction. We do this for every single row in the dataset, and then we average the results. This gives us an accuracy score called the OOB score. That is mathematically just as good as having a separate validation set, but it happens automatically while you train. So OOB helps you tune your model efficiently. So that's a wrap. Thanks for joining us on Scovia Labs. Hit that subscribe button for more eye-opening insights, and as always, stay curious.